Hello everyone, my name is Tom Gala. I've been involved in one form or another in writing music for maybe the last 30 years. Over the last 10 years or so, I've been dabbling in music production, and just this past year I sort of upgraded all my gear, and I'm looking to pursue my passions in a little bit more serious way, and so that's why I'm taking this course. So I decided to talk about signal flow through my system here. I thought that would encompass a lot of the topics that we covered in class. Sound in air starts out, it's a longitudinal pattern of compression and rarefaction at different frequencies, which would vary the pitch, and at different amplitudes, which would vary the volume. So the sound waves in the air hit the diaphragm of the microphone, and the microphone is a transducer which converts the energy waves in the air into varying electrical impulses. I'll just talk about a simple dynamic mic like the Shure SM58. The sound is captured and transferred through an XLR cable, which is a balanced cable, to my digital audio interface. I'm using the Roland Octacapture. You can see here it has 10 ins, 10 outs. It's 24-bit, 92 kilohertz sampling rate. So these inputs here, you can see the first two are instrument inputs, high Z, so you can plug your guitars into them, but they're multi-purpose inputs. You can also plug your XLR cables, that is to say your microphone cables, into any of these as well. So there's 4 inputs in the front. There are also 4 in the back, but we'll get to those in a minute. You can see we have the preamp, which is used to bring various signals up to line level if needed. There's your 48 volts of phantom power for your condenser microphones. Quickly looking at the back, you see the other 4 inputs here. Here you have a slew of outputs. Note the main left and right outputs, which are connected with a 1/4 inch balanced cable to my studio monitors. Also note here the MIDI in and out. I use a lot of MIDI with my in my projects. Here you have the USB connection to the computer and the power source. We talked about how sound starts out as pressure variations in the air, and then gets picked up by the diaphragm of the microphone, which is a transducer, and it converts it to electrical variations along the cable into the interface. What happens at that point is the interface converts it into digital information that the computer can understand. So here we can see the various tracks in this particular project. This here is an audio track, so anything that we recorded with our microphone could be potentially on this track here. The first button on the track you see is the gain. The gain is set at unity, which is to say it's not affecting the signal in any way, so that's the optimal setting there to lessen the noise to signal ratio. So once the signal is passes through the gain stage, it can be affected by various plugins, compressors, EQs, etc. Signal travels down and is controlled by the output fader, and this particular track is being routed to the main audio bus. After the signal leaves the master bus, it is converted from digital back to analog and is sent out of the main outs in my interface to my studio monitors, which convert the electrical impulse back into pressure variations in the air. I want to thank you for listening, and to those of you who are reviewing my presentation, I want to thank you for your time and efforts as well. I have to say I'm thrilled with the course. Again, I've been dabbling in music production for the last 10 years, but I feel that this course is just what I need to fill in some of the gaps in my knowledge and kind of bring it all together. So thank you, and enjoy the rest of the course.